Alright, let's go ahead and get started. This is test 4.1 review. So let's go ahead and look at the first one. It says write in logarithmic form. So I'm going to start with number 1. So I have 2 to the 4th equals 16. Now this is in exponential form, so I want to convert it to log form. So how I do that is I write the word log, and log have bases. So I'm going to read left to right. The first thing I see is a 2, so that becomes my base, log base 2. 2 whoops to 16, so I'm going to write 16, and then 16 whoops to 4. Crosses the equal sign, so equals 4. Just like that. So I have log base 2 of 16 equals 4. I like to tell my kids I double whoop because I'm an Aggie, and Aggies like to whoop, so double whoop. So the inverse of log is exponential. So if we have an exponential, we get log. Vice versa, if we get log, we're going to go back to exponential, which is the same thing like number 3. If you guys look at number 3, it says log base 16 of 4 equals 1/2. It says write in exponential form. How I'm going to do that is the same thing. Read left to right just like you read a book. First number I see is 16. That's what I start with. 16 whoops to 1/2. So instead of having a base, this is exponential form, so I'm going to write it as an exponent. 16 to the 1/2 power, 1/2 whoops to the argument, which is 4. There's my answer. When we have a logarithm, guys, say I have log a base a of b, this right here is called your base. This is your argument. And then whatever this equals to, say this is some c variable, this would be your answer. So base, argument, answer. This is all parts of the log. Alright, so I'm going to go to number 5. Number 5 says evaluate the log expression. So I have log 1/3 of 27. So I'm going to equal this to x. And to get rid of the log, I'm going to write this in exponential form. So this is 1/3 whoops to x, x whoops to 27, right? So now that I'm here, I'm going to go ahead and rewrite. So to get rid of the fraction, I'm going to move this guy up. Now there's different ways for y'all to do this, so just double check your answer is correct at the end. In order to move this up, this becomes 3 to the negative 1 power. And then I'm going to rewrite 27. 27 with a base of 3 is 3 cubed. Now, power to a power rule. When you have two these staggering staircase looking exponents, you multiply them. So you get 3 to the negative x equals 3 to the 3rd. So now that I've isolated the exponential function, I'm going to cancel the 3's. You get negative x equals 3, x equals negative 3 to get x by itself. And that is your answer. Alright, so that was number 5. Let's go ahead and go to number 7. Number 7 says I have log base 4 of 0.0376. Now, if I was solving this, guys, right, I would say x. I would say 4 to the x equals 0.0376. Now I know 4 to the 0 power is 1, right, because anything to the 0 power is 1. And then 4 to the first power is 4. 4 squared is 16. You see this number right here? This number is way smaller than any of these answers. So that means I'm going to get a fractional answer. So in order to solve this, I'm going to do change of base formula from here. How I'm going to do that is I'm going to write log on top, log on bottom, and your argument goes on the top. So 0.0376, and then this will be log of 4. Now the reason why I do change of base is because, especially the old calculators, they can only do a common log. They can only do base 10. So I need to convert this to base 10. And how I do that is I type in log. Right, in my calculator, the log button is right here under the x squared. Log of 0.0376 divided by log of 4. And enter. And so I'm going to get negative 2.37-ish if I round. So that would be my final answer, which makes sense because to the 4 to the 0 was 1, and we had a number that was way smaller. Good. So now we are, let me go to number 8. I'm going to look at number 8. I have log base 3 of 729 to the 20th. I'm trying to solve. Now another way we can do this, right, there's different ways we can solve logs. I'm going to think, can I write 729, rewrite it? Well, I know that 729 is 3 to the 6th power. Just like that. So I'm going to rewrite. Okay, and then I have the power to a power rule, so this becomes log 3, and then 6 times 20 is 180. Now, right here, this should catch you right. Anytime you have log with a base and your argument's the same, and it's raised to a power, they cancel. I tell my kids it looks like a smiley face, so you're just left with the exponent. The exponent drops. So here, I have log base 3 of 3. They cancel, so you're just left with 180. So 180 is your answer. Similarly, if I have, say, a number raised to log base that number to the x, these would also cancel. I tell my kids this makes a sad face. So for instance, if I had 5 raised to the log of 5 of x, something similar like this, these would cancel, and so you would just be left with x. Alright, so let's look at number 9. Number 9, you have log base 3 of 1/9. Now I know I can rewrite 9. Right, 1/9 is your argument, so be careful here. I can rewrite 9 as 3 squared. But I can't cancel this yet. What I need to do is get rid of the fraction. So what I'm going to do is going to move this guy up. So this becomes log base 3 of 3 to the negative 2 power, just like that. So now these guys cancel, so the negative 2 drops. So your answer is just x equals negative 2. Number 10 is another change of base problem right here, right? So if I was to write, I can't rewrite 36 with a base of 5. That's my first kind of clue this is change of base. If I wrote this as an exponential, 5 moves to x, x goes to 36. I know 5 to no power gives me 36 because 5 to the first is 5. 5 squared is 25. Oops, 5, not 2. 5 cubed, that gives me 125. So you can see here my answer is going to be somewhere between 2 and 3. This is change of base. Now from here, how to do change of base, remember you log on top, log on bottom, argument is on the top, base is on the bottom. So now I can plug that straight into my calculator. Log 36 divided by log 5. So I get 2.226, so 2.23, which makes sense because we said earlier our answer would be somewhere between 2 and 3. So that is our answer.